Red 6. Let a function be defined as f of x equals 2x minus 1 to the fifth, x plus 1. Agreed?
Mhm.
And it says, which of the following is an equation for the line tangent to the graph at the point where x equals 1? So what do?
Solve for derivative. Right.
Solve for my derivative. So my derivative would be f prime of x. I got two things multiplied together, so I'm going to use the product rule. So I'm going to use the product rule. I'm going to go 2x minus 1 to the fifth. And do the first one, which is 1. Plus, I got to do 5 times 2x minus 1 to the fourth times the inside, which is 2, times the thing left alone.
Okay.
Plunk a 1 in there.
Get it.
2 becomes 1, so that's 1, 1, 1, so it's just 1, plus, put 1 in here, that's 1, that's 5, times 2, times 2, 10, 20. So I'm getting 21 as my slope. So far, so good?
Yep.
Okay, so now I have 21 as my slope. The other thing I need to do is find my point, because I only got the x side of my point. So put a 1 in here. That becomes 1 plus 2, so that would, 1 times 2. So that's 2, right? So I'm going to go y equals 21x plus b. When I put a 1 in there, I should get a 2, which means b is going to have to be a really big negative number. So with that over, I get 19. Negative 19. So y equals 21x minus 19. B. Good?
Yeah. Actually, I solved it. Okay. When I put back the 1 to solve for your y value, I put it in the f prime, not the f.
Oopah.
What do you do all day?
He sits there and plays the worm game because he's the best in the world at it.
So there you go.
What am I supposed to do?
Homework!
No, I'm just curious.
Classwork!
Oh, nothing else to do. Take me home, Padre.
Kanina rewrites.
Oh.
Kanina rewrites, like Heart of Darkness, where you got check.
You can talk to me after school like every day.
Yeah, you could. Talk to
Not
Kanina.
here.
That's right, he wasn't here today.
Okay.
Ursula. All right, so this is what, red 7 you said?
Mhm.
Okay, so I've got integral e to the x to the 1/2 because we hate that notation, right? And then here I'm going to have x to the negative 1/2 dx. Agreed?
Right.
All right, so now what do we do?
So you add. Oh, I changed e to the u.
Use e to u? I like e. E is a good thing. Change the thing that's up there. E to the power of u. I like that. So u equals x to the 1/2. So du equals 1/2 x to the negative 1/2. Agreed?
Right.
Dx. So I have the x to the negative 1/2. I do need a 1/2 there. Since I need a 1/2, I put a 2 out in front.
Oh yes, I just forgot that one side of that.
2 integral e to the u du. So that would be 2 e to the u plus c. 2 e to the x to the 1/2 power, or they probably put the square root bar back in, they did. Plus c, so that would be what, a? Mm-hmm. All right, Ursula.
12.
Green 12. Oh, this one. All right, green 12. Okay, f of x equals ln of x over x to the 99. We're taking the limit as x approaches infinity. I've got f of x equals e to the x over ln of x, and I want to know where the function would give me 0. And the last one is f of x equals x to the 99 over e to the x. All right, now, I'll be frank with you. I'm not sure why this is on the A/B test. This is a great problem for a BC, but they know a rule you do not know. So your approach has to be completely different. First thing you would look at is the x approach infinity. You're going to divide by the highest power of x. You're going to get nowhere doing that. Does that make sense?
Yeah.
But some things you could argue about and are reasonable to argue about. If you look at this, you go, all right, that doesn't work. Next step would be to put in your calculator and pick really big numbers. Well, you don't have a calculator. So you're going to have to use that thing between your ears to calculate this, okay? So you're going to look at it and you go, ln of x. Do you remember what that graph looks like? That's a bummer, because it looks like this, right?
Okay.
We did that for plant food. So this is what that looks like. Do you know what x to the 99 looks like? So which one's blowing up faster? X to 99. Now the other way to look at it, if you don't remember that, is if you pick ln as e to what power gives me x, right? So like e to the 7th would just be 7, right? So a very large x value would give you a very small ln, right? Whereas if I put in e to the 7 here, it's going to be e to the 7 to the 99th power. So it's going to blow up like crazy. Does that make sense? Okay. So which one wins? The bottom wins?
Yeah.
Which means this thing's going to 0. Right?
Yeah.
That's the first one. The second
That's
one's...
what I did is I got small number over a large number, so I was like, it's approaching 0.
Right. That one's approaching 0. That's what we're looking for. So we look at the second one. The second one, we make the same argument, but the top one is the one that blows up. The bottom one is just a little ln, so that's not going to 0. So this is going to infinity, or the limit does not exist, right?
Yeah.
So now I try the last one. Now the last one is the one that's the hard one. Okay? We did briefly talk about a rule that you could fall back on if you had to. Okay? And that's this. An x power always wins. Okay? Why would that be? Because I got x to the 99, and a million, that's going to be a million, that's going to be 99 millions. Yeah, but e to the millions, e times e times e a million times. That's a bigger number, okay? And so the power always wins. And in this case, that's what's going to drive this thing. Okay, does that make sense?
Yeah.
So this would be bigger than the bottom, so this thing would go to 0. And again, not really clear why this is on the A/B test. I mean, this is one of those things where,
What do they know that we don't?
well, they know that the derivative of the top, if it's an indeterminate form, if it's 0 over 0 or infinity over infinity, you may take the derivative of the top and bottom, and that also will give you the limit. So, for example, if they took the derivative of this thing, they would get 1 over x, and separate top and bottom. Like, you're not doing a quotient rule or anything. So this would become x to the 98 over times 99. Well, which one is going to blow up to infinity faster? Well, that will be, as you approach infinity, becomes 0. That's a free win. Same thing here, because this one goes 99x to the 98. This one becomes e to the x, doesn't change. You're like, well, that didn't really help much, except you can keep doing this, right? Eventually, the x is going to go away. This is going to stay e to the x. So it's eventually going to win. Okay? That's the rule they know. That's called the Hopital's thing. Yeah. Good?
Yeah.
So damn wild. Now I'm confused. One of those two. You're good?
Yeah.
Okay, so that's green 12. All right, Brandon.
Red 12.
Red 12. Red 12.
Red wine, you make me feel so fine, you to keep me rocking.
I probably shouldn't be singing that in the recording. Here we go. Red 12. I've got f prime of x equals 2 over x. Find f of e to the 1/2 equals 5. Then f of e equals question mark. All right. So I want to know what the function of e is, right? Now I was given the derivative, so what do?
You do the integral, right?
I got to integrate, right? So I'm going to integrate 2 over x dx, which becomes 2 ln absolute value of x plus c equals y. Agreed? All right. So they're telling me that e to the 1/2 is 5. Why are they telling me that?
Is it constant, right?
That gives me the constant, right? So I'm going to put e to the 1/2 in here. And this is where hopefully you remember some of your log rules. E to the 1/2 plus c.
You could bring the 1/2 up front.
I can bring the 1/2 up in front. Beautifully done, sir. So that's ln of e plus c. ln of e is
Cancels out, right? So there's 1.
1, right? So it's been 5, 1 plus c. C therefore equals 4. So my real equation is y equals 2 ln absolute value of x plus 4. Agreed?
Right.
Now I know what f of e is. So what do?
Plug in yourself.
Put an e in there. So y equals 2 ln absolute value of e plus 4. Absolute value is silly. ln of e is
Just one.
1. So this becomes y equals 2 plus 4 or 6. Good.
Yeah. So what do you know when it's plus or minus? Like exactly.
When you get rid of an absolute value bar, usually happens when you have an ln of absolute value of x equals, say, well, that's terrible, y equals x. Get rid of the ln by going e to the x. I got absolute value of y. Then when I go to get rid of the absolute value, that becomes a plus or minus. That's how you get rid of absolute value bars. Okay? It's 2 solutions you have there. Ursula!
19 on green.
19 on green. Both of you keeping to your favorite test. 19 on green? All right. 19 on green. Ooh, this is weird looking. All right, 19 on green. So this is, I've got some sort of function like this. I've got this thing coming down. It goes here. It goes up like this and then back down. I've got a line tangent to it. Okay, the line tangent does have 2 points located on it. Agreed? And I've got nothing else there. Okay, so probably that's a line tangent by the look of it, but I can't say that for sure just yet. The figure shows a graph of a function g and a line tangent to the left at g at x equals -1. Agreed? Let h be the function h of x equals e to the x times g to the x. What is the value of h prime of -1? So I'm asking for h prime given I got 2 functions multiplied together. What's the rule? Product. So I'm going to go h prime of x equals e to the x g of x plus e to the x g prime of x. Agreed? All right. So h prime at -1 would be equal to e to the -1, g to the -1, g at -1, I should say that's better, plus e to the -1, the derivative at -1. Okay, so what is g at -1?
3.
3. This becomes 3 over e plus, what is the derivative at -1?
-1. No, just kidding.
Slope would be down 6 over 1. Is
Yeah.
that right? Seems really steep, but I guess that's it. So the derivative would be -6, wouldn't it?
Yeah.
Over e. So I get -3 over e.
Thank you.
That good?